Composition of functions. Composition means there's multiple. We're doing multiple, or composition of reflections. I'm sorry, I did functions last period. Composition of reflections. Okay? Composition means multiple reflections. So in other words, we want to see what happens to a figure when we reflect it multiple times. And so today we're going to reflect across intersecting lines and across parallel lines. The first thing I need you to do is read through these two theorems and draw a picture describing them. So theorem 3.1 and 3.2. And then I want you to define what a glide reflection is and answer the questions there about isometries. Okay? So kind of go through that. You guys get about 10 minutes to work on this. That's it. Okay? Ready to go. You guys should now have some background knowledge. Okay? Hopefully at least you looked up what a glide reflection was. You looked up theorem 3.1 and 3.2, even if you maybe didn't understand them, but you read through them and talked about reflecting across what types of lines? All right, let's pause. Hey, we want full participation, otherwise you're using the book the rest of the class. Okay, reflects across what types of line?
Two parallel lines.
Parallel and?
Two
intersecting. Don't have to be perpendicular. They could be, they don't have to be. Okay? And then hopefully you define what a glide reflection is. What is a glide reflection, just out of curiosity? Carson?
A glide reflection is a composition of like three reflections in a line that intersect.
Okay, could be, yeah. What else is a glide reflection? Yeah?
So it moves the image from one area to the next and then flips it.
Okay, so it does two types of, it does two transformations. It does a glide, which is the same thing as a translation, and then a reflection. Yeah, so it glides and then reflects, like Maddie said there. Okay, so what I want you to do right now is I want you to take a look at this. I want you to go through and I want you to go through and make this on a piece of paper. I want you to make a tic-tac-toe board like that. Give yourself some space so we can go through it together. Doesn't have to be on graph paper. It can just be on regular paper. I just happen to have a piece of graph paper with me.
Emma.
All right. Now, just so that we have a reference, I am going to number my boxes so that I can reference the box number. So it breaks it into 9 boxes. 1, 2, 3, 4, 5, 6, 7, 8er, and 9er. All right. There we go. Cool? All right. So what we're going to do is we're going to put an L. Now when I make my L, it needs to be profound. It needs to be an L with a longer side. Sorry. So one side must be longer than the other, so you can actually tell. Okay? There's my L. So hopefully that shows up okay. Yep. Letter L. And what I'm going to do is I'm just going to start reflecting that L. I'm going to reflect it across every line. So I'm going to reflect it across this line over to here. I am then going to reflect it this way. I am then going to reflect it this way. And then once I have that, I'm going to reflect this one down or that one over. I'm going to fill all these boxes with reflected L's. Okay? Yes?
Do you want it the same units as yours?
It doesn't have to be the same units as mine. It just needs to be able to tell that this is the longer side, that's the shorter side. Okay? Go for it. You guys get about 3 minutes. Here we go. Now that you've reflected your L across, now I'm hoping everyone, so I've got my L there, and then I've got this L here, and then this guy, oops, My apologies. There we go. That guy there. Oop. Too big. Thank you. All right. Someone's checking my work, right? All right. My 7's getting in the way there. And let's see. All right. There we go. Everyone out there else? Yours match? Okay. Now what I want to do is I want you to take a look at these two lines. We're going to focus in on this line and that line. Those lines, tell your neighbor what's unique about those lines.
They're parallel.
They are parallel, right? Parallel. Okay. Now if I start with image 6, that's my pre-image. Let's say pre-image 6, and I reflect across two parallel lines. So Grace, this is what we're talking about. Okay, I reflect image 6 across two parallel lines. That brings me to image what? No. From 6 to there, then to there. So from 6, reflect once, and then across another parallel line, it goes to 4. Yeah, it's the same as what single transformation we've already studied. Yeah. Okay, I want you to talk to your neighbor. When you're reflecting across parallel lines, the pre-image and the final image are the same as what? And you could look at this one as well. Okay? Go ahead and tell your neighbor what are they the same as. Translation. Okay? From 6 to 4, we're doing a translation. Now, if I look at a reflection across intersecting lines, so maybe focusing in on this line here, we'll call that line L and line M. Okay? If I reflect this figure right there from that point, and then I reflect it here, and then I reflect it again across that intersecting line, so from pre-image to image, from 5 to 1, what really have I done there? What single transformation that we've already studied? I want you to tell your groupies. You get about 10 seconds. Okay, so what is it, Carson? Same as the rotation. Notice if I have 5 and I rotate about this point, I'm swinging it up, it's the same as having a rotation. When I reflect across intersecting lines, the single transformation, if I do a composition, so once and then twice, it's the same as rotating that figure. Okay? Not rotating the page. If I reflect across intersect or parallel lines, so like this line and this line, so from there to there and to there, that's the same as having a slide or a translation. Okay? So when you do a composition across parallel, it's like a slide. Across intersecting, it's like a rotation. Okay, so those are two of the things we're dealing with today in terms of composition. That's what your theorems described. All right, so you guys need to summarize those theorems just really quick about parallel and intersecting lines, and then we're going to go on to glide reflection. Carson had a good question. The lines you're intersecting, they don't have to be perpendicular. Okay, they can be any intersecting line. So if I had these two lines, and I wanted to reflect, thank you. There we go. If I wanted to have that, and then I wanted to reflect that over to here, okay, and then I wanted to reflect that down to here. Man, I made that a difficult piece, but you can go ahead and let me see if I can get that. Be way down here, and I'm thinking be about like that. Okay, you'd still have that rotation. Okay, but the lines don't have to be intersecting, so it won't always be a complete right angle intersection. Okay. All right. Next piece. Looking at example 3 real quick. Some of you already read this, but this is talking about glide reflections. Okay? Example 3 in your book. Find the image of tex, T-E-X, under a glide reflection where the glide is given by a vector of 0, 5. So in other words, we're sliding it to the right or left, 0 units, and we're sliding it down 5 units. Okay, so the first thing we've done with text is we slid it down 5 units, so we have our vectors here. And then we're reflecting it on x equals 0. Well, x equals 0 right here. The x equals 0 line happens to be your y-axis. So when I reflect across the y-axis, that moves this point here, e prime, x prime, and t prime. So you've done a glide reflection. Okay? Would we have got the same thing if we would have reflected it and then, or excuse me, reflected it and then glided down?
Yes.
Yeah, if we would have reflected first, that would have been here to here. Did I get that right? Yep. There to there and to right there. Okay? And then we slide down 5. 1, 2, 3, 4, 5. We're there. There and there. So we still would have been at the same locations. Okay, E prime, T prime, and X prime. It doesn't matter if you do the gliding first and then reflecting, or the reflecting then gliding, you get the same result. Okay? I want everyone to tell your neighbor where the line y equals negative 2 is on a graph. If you got it right, yeah. Good. Negative 2, and it's parallel to the x-axis. A great way to describe it. That is the line y equals negative 2. How many got it right? It's a big deal when you're dealing with reflection. So I'm not going to actually find the image of a glide reflection of this. But when I'm reflecting across y equals negative 2, that is that line. That's an important piece. If it's a y equals, it only crosses the y-axis. If it's x equals, it only crosses the x-axis. Okay? If you didn't learn that in algebra, that's something you definitely want to write down, or if you'd forgotten it. Okay? Any questions? All right, very good. Tell your neighbors the 4 isometries we've studied so far this chapter. Okay, isometry means it doesn't change size or shape. These are the 4 we've studied. It's a big deal because the next the next lesson, actually, I guess a couple lessons from now, we're going to be studying ones that are still transformations, but they change size and shape. Therefore, they're not isometries anymore. They're enlargements or reductions. How many remember what orientation is? Tell your neighbor what orientation is. Okay, close your books, please. Textbooks closed. All right, there we go. Tell your neighbor what isometries those are. Okay, number 5. What is it? What do you think, Grace? A rotation. How do you know it's not a reflection? Still like 5, it's just moved. How? What's another way of saying that? Yeah. It's the same orientation. If it's a reflection, the orientation changes. Or it's in reverse order. Here the orientation's changed. Letter B has to be a reflection, or what's the other one that's a reflection? Glide reflection. It's either a reflection or a glide reflection. Letter A has to be either a rotation or a translation. Well, it's obviously not a translation, so it's a rotation. Letter B, it's not reflecting straight over, therefore it's been slid and then reflected, so it's a glide reflection. Orientation helps you determine which of the 4 it is. Okay? Any questions? All right. So rotation and glide reflection. And if you guys want to abbreviate it like that, that's okay. Glide reflection. All right.